In India, every occasion to celebrate life revolves and evolves around food, and that translates to a generous use of edible oil. Edible oil is a hallmark of India's food culture. But there, the question arises, considering our increasing population, are we producing enough edible oil? The fact remains, production of oil is less to meet vegetable oil demand in India. So while demand for edible oil is skyrocketing in our nation, the gap between its demand and supply keeps getting wider and wider. There is an urgent need to bridge this gap. But how? Import of vegetable oil means a huge spending of foreign exchange. Isn't there another way? Can't India be self-sufficient in the production of edible oil? Yes, we can. But we might have to take help of oil palm, the golden palm. This golden palm, originally from Africa and popular in Asian nations like Malaysia and Indonesia, has arrived to stay in India. But India is still to catch up to its full potential. That will happen only when our stakeholders get to realize its vast usage and high productivity potential. To meet the increasing demand of edible oil in our country, Indian Institute of Oil Palm Research at Pedavegi in West Godavari district of Andhra Pradesh has been entrusted the responsibility of conducting research on all aspects of oil palm. The institute has developed various farmer-friendly production technologies to enhance the productivity. ICAR-IIOPR focuses on different packages of practices to be adopted by growers for successful cultivation of oil palm, which will help in bridging the gap between demand and supply. Oil palm can be a catalyst to meet our vegetable oil demand and nutritional security. And India has just the right conditions to grow it. A humid tropical crop, oil palm can grow well under well-distributed rainfall of 150 millimeters per month in areas like Kerala and Andaman Islands. In other areas, oil palm cultivation could be taken up with assured irrigation. For the best yield, the crop requires temperatures between 22 degrees to 33 degrees Celsius, bright sunlight of at least 5 hours per day, altitude up to 450 to 900 meters above mean sea level, relative humidity of more than 80%, and good management conditions. The best suited soils are moist, well-drained, deep loamy alluvial soils, rich in organic matter with good water permeability. High alkaline, saline soils, waterlogged and coastal sandy soils need to be avoided. The oil palm hybrid Tenera is used only for commercial cultivation. The high-yielding palm is a hybrid, cross between thick-shelled Dura as a female parent and shellless Piscifera as a male parent. Nursery can be raised by double-stage system. Sprouts are dibbled in small-sized polythene bags and kept under shade. After 4 months, these are transferred to bigger polythene bags and arranged at a spacing of 75 centimeters in a triangular fashion so as to accommodate more seedlings. Mulching during nursery stage is desirable to conserve moisture. Care must be taken to give irrigation by drip method. Field must be thoroughly plowed and leveled before taking up the planting. Equilateral triangle or square method of planting can be followed. In triangular method with 9-meter spacing can accommodate 57 plants per acre or 143 plants per hectare. In the square method, 47 plants per acre or 123 plants per hectare could be accommodated. Prior to planting, pits are dug and they are allowed to season. The pits should have 2 feet length, 2 feet width and 2 feet depth. Digging the pits with the help of post-hole digger will save labor and time. It can dig the pit within 2 to 3 minutes. The seedlings ideal for transplanting are 12 months old, healthy seedlings having 1 to 1.2 meters height and 12 functional leaves with 20 to 25 centimeter girth at the collar region. The seedlings should be transported to the planting site only at the time of planting. Apply 400 grams of single superphosphate or 250 grams of diammonium phosphate, 50 grams of phorate and 1 basket full of farmyard manure and mix with dug up soil in the pit. The polybag should be removed by making longitudinal cut and seedling is kept in the pit. The gap in the pit should be filled with the soil and pressed firmly, leaving top portion so that the seedling bowl will be 25 centimeters below ground level. Enough care should be taken not to accumulate soil around the crown. Soon after planting, form a basin around the plant and give copious irrigation. During the first year, take 1 meter radius basin around the palm by removing soil from inside the basin to prevent accumulation of soil at the collar region. During second and third year, widen the basin radius to 2 and 3 meters respectively. The best period of planting is June to December, but planting can be done in any season. During summer planting, adequate irrigation, mulching and sowing cover crops like sun hemp in the basin would help to overcome the heat. For a healthy growth, lower dried and diseased leaves should be pruned selectively. Retain 33 green leaves on an adult palm. Severe pruning adversely affects growth and yield. The basin area of oil palm represents active root zone. This requires regular weeding to avoid competition for nutrients and water, either manually or through use of herbicides like glyphosate or Gromoxon at the rate of 2.5 milliliters per liter of water or 750 milliliters per hectare. Mulching, growing cover crops and intercrops minimize weed growth and help to conserve moisture. Oil palm, a fast-growing crop, requires adequate irrigation, without which it develops unopened spindles, leading to reduced leaf production, decreased sex ratio, abortion of inflorescences, and reduction in yield. It is not recommended to cultivate oil palm without assured irrigation. For grown-up yielding palms of 3 years age and above, it is required to provide 100 to 150 liters of water per palm per day in rainy season. During winter season, 160 to 170 liters per palm per day, while a minimum of 215 to 265 liters of water per palm per day is required during summer. However, in older plantations during hot summer, this amount may be increased up to 300 to 350 liters. Generally, drip or microjet irrigation is to be adopted for economic use of water. In drip system, 4 drippers have to be placed at 4 sides of each palm. If each dripper discharges 16 liters of water per hour, 4 to 5 hours of irrigation per day is sufficient. Drippers should be checked periodically for proper discharge of water. In microjet system, 2 jets have to be placed on either side of the palm. If each jet discharges 40 liters of water per hour, 2 to 3 hours of irrigation per day is sufficient. During summer, the amount of irrigation may be increased based on the potential evapotranspiration. However, running irrigation channels along the palm rows is not recommended in basin system of irrigation. Mulching can be done by using dried oil palm leaves, male inflorescences, empty oil palm bunches, or any other materials like coconut leaves, coconut husk, cocoa pod husk, and chopped maize stalk. Immediately after harvesting of oil palm bunches, leaves can be cut into small pieces by using shaft cutter and used as mulch in palm basins. Oil palm, a gross feeder, demands a balanced and adequate supply of macro and micronutrients. For newly planted crop, the first dose of fertilizer should be applied 3 months after planting. The recommended dose of fertilizers can be applied in the form of straight or complex form, depending on their nutrient contents. For the first year, 870 grams of urea, 1250 grams single superphosphate, 670 grams murate of potash, 125 grams of magnesium sulfate, and 25 grams of borax. For the second year, 1,740 grams of urea, 2,500 grams of single superphosphate, 1,333 grams murate of potash, 250 grams of magnesium sulfate, and 50 grams of borax. And from the third year onwards, 2,610 grams of urea, 3,750 grams of single superphosphate, 2,000 grams of murate of potash, 500 grams of magnesium sulfate and 100 grams of borax need to be applied. The fertilizers are broadcasted and incorporated into the soil using a racker around the clean weed-free basin, about 2 feet away from the palm base, near the absorbing roots. In plantations having micro-irrigation, fertilizers need to be applied near moisture zone. The palms should be irrigated immediately after fertilizer application. Fertilizers are to be applied in 4 equal split doses during the year. With the second dose, add 50 to 100 kilograms farmyard manure or 100 kilograms green leaf manure per palm. 5 kilograms of neem cake per palm can also be applied. However, when organic manures are applied adequately, the amount of chemical fertilizers for nitrogen should be proportionately decreased. Fertigation with NPK at the rate of 600:300:600 grams per palm per year at monthly intervals, coupled with irrigation based on potential evapotranspiration, is recommended for higher FFB yield. The recommended fertilizer doses when fertigation was followed were 1,050 grams of urea, 652 grams of DAP, and 1,000 grams of murate of potash per palm per year. Per acre, it is 60 kilograms urea, 37 kilograms of DAP, and 57 kilograms of murate of potash per year. Equal splits of these fertilizers should be applied in a year at monthly intervals. A good harvest of oil palm depends on efficient addressal of nutrient deficiencies. Magnesium deficiency, occurring in the form of orange frond in older leaves, can be overcome by applying 2 kilograms of magnesium sulfate per plant per year. This should be followed by soil and leaf nutrient analysis. Symptoms of boron deficiency are blind leaf, hooked leaf, crinkling of leaf, and fishbone leaf on the younger leaves, which are easily identified on the field. Borax at the rate of 100 to 250 grams per plant per year is recommended, followed by soil and leaf nutrient analysis. In case of nitrogen and potassium imbalance, narrow bands of chlorotic tissue appear in the pinnae. The stripe may be at any portion between the midrib and edges of the lamina. Application of 2 to 3 kilograms of murate of potash per palm per year is recommended, followed by soil and leaf nutrient analysis. Potash deficiency symptoms are seen in the form of confluent orange spotting on older palm leaves. Application of 3 kilograms murate of potash, followed by soil and leaf nutrient analysis is recommended. Green manure crops like sun hemp are grown in the basins of young oil palm plants of 1 to 3 years of age. After flowering in 60 to 65 days, they are cut and incorporated in palm basins. Besides helping in soil and water conservation and checking weed growth, This provides a better microenvironment during summer, fixes atmospheric nitrogen, and adds organic matter to the soil. In oil palm gardens, wide space is available during the juvenile period of first 3 years that could be used for intercropping for additional income. Shade-loving and shade-tolerant intercrops should be selected that should not compete with oil palm for light, water, and nutrients. The crop selected for intercropping should be compatible with the main crop and should not compete with oil palm for light, water, and nutrients. Crops like maize, banana, tobacco, chilies, groundnut, pulses, flowers, and vegetables can be taken up as intercrops. In case of banana, maize, and sugarcane, sufficient space should be given to avoid shade on oil palm. While intercropping oil palm with oil seeds and pulses that require less water, adequate care should be taken to irrigate the oil palm regularly. While raising intercrops, avoid tying or cutting of oil palm leaves as this reduces photosynthetic activity. Plowing close to the palm base should be avoided as it damages absorbing roots, leading to reduced intake of water and nutrients. Grown-up oil palm gardens could intercrop with cocoa, long pepper, bush pepper, flower crops like red ginger and heliconia. It is also possible to make the farm self-sustaining by taking up mixed farming, integrating oil palm with fodder crop, dairy, and farmyard poultry. Oil palm flowers at 14 to 18 months, producing both male and female inflorescences separately on the same palm. Ablation involves removal of male and female inflorescences produced during juvenile stages. It should be done using ablation tool immediately after appearance of inflorescence. This helps the plant to gain adequate stem girth, vigor, and develop adequate root system. Oil palm is a highly cross-pollinated crop, though pollination is assisted by wind and insects. Depending only on wind, pollination is not adequate. Pollinating insects like Elaidiobius camerunicus help in good pollination and fruit set. The weevils should be released after 2.5 years of planting. If the palms do not develop good girth and vigor, the weevils should be released after 3 years. Rhinoceros beetle is one of the most damaging pests. Its damage symptoms are seen in the form of wedge-shaped gaps in the leaf silhouette, permanently marked hole on petiole regions of the leaves and outermost spear of the leaf due to the beetle's penetration. Damage symptoms are also seen on unopened spindle. Adult beetles tunnel into crown of the palm at the base portion and eat the soft tissue or sap. This hole may allow the red palm weevil and bud rot causing fungus to enter into the crown, causing bud rot. Partially rotten farmyard manure or compost should never be applied as they contain grub stages of the pest. The beetle can be controlled by destroying the breeding sites. Maintain sanitation in the orchard. Trap the adults with fermented castor cake bait or pheromone traps and kill the adult beetles. Treat compost pits with insecticides like chlorpyrifos. Dust regularly to kill the young stages of the pests. It can be controlled biologically by using green muscardine fungus, Metarrhizium anisopliae. The fungal pathogen can be applied on breeding sites like farmyard manure pits and dead logs. Keep 20 grams of phorate granules in perforated polythene sachets in axis of spear leaf. Change the position of the sachet every month by keeping in a new spindle. Formation of case is the characterized symptom of bagworm attack. Young larva scrapes the epidermis, while mature one makes a hole in the leaf. Appearance of short holes on leaves is an indication of severe outbreak of pest. Attack of this pest could be controlled by cutting and burning the infested leaves. Adopt root feeding with monocrotophos at the rate of 10 milliliters in 10 milliliters of water. Stem injection with monocrotophos at the rate of 20 milliliters in 100 milliliters of water, or spray lambda cyhalothrin at the rate of 1 milliliter per liter of water. Use biological control agent like Bavaria bassiana. Leaf webworm is a pest that infests lower leaves and causes rectangular holes on leaf lamina. Larvae are found inside the white silken gallery. In severe cases of infestation, heavy defoliation is noticed. Leaf webworm can also be controlled by root feeding with monocrotophos at the rate of 10 milliliters in 10 milliliters of water, or stem injection with monocrotophos at the rate of 20 milliliters in 100 milliliters of water, or spray lambda cyhalothrin at the rate of 1 milliliter per liter of water. Drench the basin with malathion or quinolphos at the rate of 2 milliliters per liter of water to stop the migration of pests to other ponds. Release egg parasites like Trichogramma embryophagus. Birds can cause damage to the mesocarp of oil palm fruits, resulting in fruit drop and oil loss. This is controlled by covering the fruit bunches with wire mesh or chicken mesh or dried oil palm leaves after 150 days of fruit set. Also use fish net to trap birds. Tie the nets between the palm rows at the rate of 5 nets per hectare, preferably using green or violet colored nets. Use caring or alarm sounds as bioacoustics. The most common oil palm diseases are bud rot, stem wet rot, basal stem rot, and bunch rot. Plants affected by bud rot show yellowing of spear leaves, subsequently turning to brown. The spear then collapses and can be easily pulled out. To control this disease, affected tissues in the crown are removed and drenched with 0.1% solution of streptomycin sulfate plus carbendazim. When the disease is in the advanced stage, leaves surrounding the spear should be cut and affected tissue should be removed layer by layer till fresh tissues are seen and smeared with 1% streptomycin sulfate plus carbendazim paste. Stem wet rot infestation is seen as a chocolate-brown discoloration of the leaflets of the outer whorl of the leaves, followed by necrosis, which is the first symptom on the crown. Necrosis progresses towards the inner whorl of the leaves and results in death of the palm. To detect the disease, pierce a sharp iron rod or auger into the bole region, which gives out a yellowish liquid. If the liquid gives putrefied smell, the palm should be subjected to trunk surgery immediately. Trunk surgery removes the affected fibrous tissues from inside the trunk. Outer stem tissues and frond buds should be chiseled and the innermost diseased tissues removed first. This should be followed by the pasting of a protective covering with streptomycin sulfate plus carbendazim plus monocrotophos. Follow this with application of hot coal tar to protect the wound from invading microorganisms. If the disease is in its initial stage, root feeding or stem injection with 1% streptomycin sulfate is to be given 3 times at 5 to 7 days interval. The symptoms of basal stem rot are withering, yellowing, and orange discoloration of the leaves, followed by necrosis on one side of older leaves, with appearance of light brown lesions or rotting of bole to fibrous mass at stem base. Desiccated leaves drop or break at some point along the rachis. The disease also produces dry rot of internal tissue at base of trunk. Basal stem rot can be controlled by removal and destruction of the dead and diseased palms to prevent the spread of the disease. The affected palm should be isolated from neighboring palms by forming a trench 1 meter deep and 30 centimeters wide at 3 meters diameter from the palm base. The affected palm should be given 5 kilograms of neem cake per year. Combine this with soil application of Trichoderma species, multiplied on farmyard manure at the rate of 5 to 15 kilograms per palm at 2 to 3 months interval. Adequate moisture level should be maintained while applying Trichoderma species in soil. Combine this with application of organic manures in the palm base to maintain the biocontrol agent in the soil. During early stages, bunch rot affected oil palm shows strands of mycelium spreading over bunch surface. This is particularly more at the back of the bunch against the subtending leaves where conditions are very moist. At later stages, mycelium grows over the fruit surface and penetrates mesocarp, leading to bunch rot. To manage the disease, remove the dead inflorescence, bunch stalks, aborted bunches before onset of the monsoon and after each harvest. Clean the infected palms and spray carbendazim at the rate of 1 gram in 1 liter of water during pre-monsoon, monsoon and post-monsoon. Also, maintain crown hygiene and follow ablation in palms of below 3 years of age. Harvesting must aim to recover the whole mature bunches. Oil palm bunches are mature when black-colored fruits in the bunch turn to yellowish-orange and 5 to 10 fruits from the bunch drop on their own. At this stage, if the fallen fruits are pressed hard with fingers, orange-colored oil exudes from the fruits. In younger plantations, harvesting needs to be done with a chisel or with a motorized chisel. While in older plantations, this could be done by using a sickle attached to an aluminium pole or with a tractor-drawn hydraulic lift platform, using an aluminium pole along with sickle or with motorized sickle. While harvesting, leave a stalk length of 5 centimeters along with the harvested bunch. After harvesting of fresh fruit bunches, transport them from farm to collection center by means of a bullock cart, tractor, auto, etc. Suitable measures are to be taken to reach the collection center without much delay and damage to the bunches. The major use of palm oil is cooking. The oil also has a perfect balance of saturated and unsaturated fatty acids, which do not adversely affect cholesterol levels. That apart, it is also used to make various value-added food and non-food products like biscuits, soaps, ice creams, detergents, shampoo, margarine, and cooking fat, etc. And that's not all. Around the world, palm oil and its derivatives are being used for various other uses. Oil palm produces crude palm oil and palm kernel oil. Palm oil is good for health. Rich in vitamins A and E, it can become our catalyst to meet our vegetable oil demand and nutritional security. When we accept and appreciate the fact that the oil palm can work wonders for a nation like ours, provided we work towards making it possible, together, oil palm can be our golden palm. We just need to join together to make it happen.